Hello again, HDExaminers. This is Jeff Morrow with Sierra Analytics, and I'm here to tell you about the new features in HDExaminer 3.2. There's a lot of cool stuff in this one, so let's begin. First of all, we have the means of adding various notes to your project, notes and annotations and such. These don't have any effect on the functionality of the software. They're just notes that you can put in the project for your own benefit. So let's start with the ones on the heat map. So if you go to heat map options, you'll see that there's this checkbox for heat map annotations that determines whether they are shown or hidden. And then to add annotations, you just right-click on your heat map and select Heat Map Annotations. So you can add one. Let's say we want from residues 21 to 33, and we want this is interesting on it. And let's make the text color white, and let's make the bar color some kind of dark purple, and hit OK. And now we have, in addition to our heat map, we have this bar that we just told it to put in, purple with the text we specified. You can, here in heat map annotations, you can add as many of these annotations as you like. You can remove them if you don't need them anymore, and it's pretty flexible. But that's not the only way you can add notes to your project. In addition to the heat map annotations, you can also add notes at the project level, at the protein state level, or attach to individual peptides or experiments. So to do that, you simply select the thing you want to attach notes to, right-click, and here, since we've selected the project, we can see project notes, and this is a ligand binding experiment. And now you'll see that here on the project, the little notes icon has appeared. And if you mouse over that notes icon, it shows you what you typed for your note. If you go back to the project notes, you can just edit them however you like. So that's pretty simple. And again, you can attach to the project. You can attach to a protein state. This is my protein state. Again, the icon shows up, and if you mouse over it, you get the text. At the peptide level, you can say peptide notes, and you can say something like, not sure why this peptide isn't showing up in the data. There's the notes icon, and you mouse over it, and there's that. Similarly with experiments, if you select an experiment notes. This is a mass spec experiment. And again, by now, you know what it's going to do. It's going to show this icon, and it's if you mouse over it, it shows your notes. So those are a whole bunch of different ways you can add annotations to HDExaminer, either in objects over here on the left-hand side or as residue ranges here in the heat map. The next new feature in HDExaminer 3.2 is that the software no longer treats charge states as pseudo-replicates. So what does that mean? Earlier versions of HDExaminer would take multiple charge states for a peptide and treat them as sort of pseudo-replicates for the purpose of statistics. After talking with some researchers and some statisticians, we've come to the conclusion that that is not justified because charge states are insufficiently independent from one another to be considered independent replicates for the purposes of statistics. So now what the software does is it draws confidence intervals relative to only the best charge state, even if you have multiple charge states. Now what this means is that you're going to generally see larger confidence intervals than before. We apologize for the inconvenience, but this is a more mathematically rigorous way of doing things, and therefore less likely to mislead you into thinking that you have a significant difference when in fact you don't. The next feature I'd like to show you is the ability to set a fixed ion mobility range for your calculations. So here under Tools, Options, Ion Mobility, you'll notice there's a new section up here at the top. So this stuff was all what was there before, and now you can choose between an optimized ion mobility window or a fixed ion mobility window. So what does this mean? So if you've watched our earlier videos, you know that when HDExaminer is trying to find a peptide in your data, what it will do is it will look around the retention time range where it's expected to be found, and also the drift time range if you're using ion mobility. And it will find a range in both of those axes. But then after it finds a result, it will try to tweak those ranges a little bit to get a better result by, for example, minimizing interfering other signals that might be nearby in either retention time space or in ion mobility space. So previous versions of HDExaminer did that in both the retention time axis and the ion mobility axis. But those of you who work with ion mobility may know that in general, drift time reproducibility is much, much, much better than LC retention time reproducibility. So while the tweaking and wiggling the range makes sense in the retention time axis, it doesn't always make sense in the ion mobility axis, and doing it unnecessarily in the ion mobility axis can cost you extra calculation time. It makes HDExaminer take longer, sometimes unnecessarily. So now, in addition to having the optimized ion mobility window like it had before, you can now tell it to only use a fixed ion mobility window within a certain number of scans to the left or to the right of your expected ion mobility. So by setting this, you're telling HDExaminer to only ever use a certain range in ion mobility space, and to not use the optimization algorithm to try and tweak it. The last feature I want to talk about is the new heat map confidence algorithm. So what is that? Well, here under the heat map options, you'll see one of the options is show heat map confidence, either per time point or unified. We'll pick unified for now. What that does is it adds another row to your heat map that is confidence ratings. Now, those of you who've used HDExaminer for a while know that we're all about confidence ratings. You know, green is high confidence, yellow is medium, red is low confidence. And that's kind of what's going on here. But what does it mean? What is this telling you? Well, so as you may know, to generate a heat map from HDX data, you first need to use your peptide coverage to break your protein up into resolvable chunks. And then what you do is you solve a least squares problem to find the deuterium occupancy on each of those chunks that best matches your measured peptides. So this is all a giant matrix algebra problem, essentially. And it's described in a paper by Babbage and Smith from a few years back. There's a link to that paper in the description below. HDExaminer uses a method fairly similar to the one described in that paper. Now, when you're doing this kind of big least squares linear algebra problem, there are two potential issues that can trip you up. The first is when your peptides don't tell a unified story, specifically when your peptides don't agree with each other very well. So since we're all scientists, we know what a scatter plot with a trend line looks like. And you've probably seen lots of these, and you know that sometimes the trend line can match very well to the data, and sometimes the trend line matches not nearly so well. Well, the exact same thing can happen here in the heat map. What's happening is your measured peptides are the data points, and the heat map that we calculate is the trend line, quote unquote, going through those data points. So the model, the heat map that we're calculating can match the data extremely well, or it can match not so well. That's what the confidence is telling you here. So green means high confidence. That means there's very good agreement between the peptides that cover that section of your protein. Yellow means it's okay. The peptides kind of disagree, but they mostly are all right. And then this light red, I'll get to the dark red in a second. This light red tells you that there are outliers. It tells you that the peptides in this region really don't tell a very consistent story, and the peptides and the heat map model that's calculated from it do not match each other very well. Now, this could be because of a bad measurement. It could be because of an outlier. It could be because of something like that your peptides have very different back exchange rates through here. The software doesn't actually care why the peptides disagree with each other. It's merely reporting that they do, and it's up to you to go in and try to see what the problem is and where the discrepancy is. Now, you'll notice that there's green, yellow, and red like elsewhere in HDExaminer, but there's also this darker red. Well, what does the darker red mean? It means that unfortunately, the least squares problem, the big matrix algebra problem I talked about earlier, has infinite solutions in this section of your protein. That means that there are an infinite number of solutions that are equally good from the standpoint of least squares. There are two other parts I want to talk about with this. One is, as I showed earlier, there are two options here, unified or per time point. Now, as you may know, each of these time points in the heat map is its own separate matrix algebra problem. Therefore, they all have confidence individually. So you can turn those on one by one, and you can see, it's a confidence for 10 seconds, and then the 10-second heat map, 100-second confidence, 100-second, etc. Now, this can be a little hard to read. So we also offer this unified thing. And in this case, as you saw before, there's a single confidence level, a single confidence row at the top, and then your whole heat map. The way the unified confidence row is calculated is it simply takes, for each residue, it takes the worst confidence of all the time points at that residue. Now let's go back to the per time point version, because I want to show you something else. By default, the software will not color any low confidence residues. So you see these are empty because they're low confidence and so forth. Now you can turn that off. You can say color low confidence residues, but as you can see here, the software will warn you that this is a bad idea. So we recommend that you not use this. Now, previous versions of HDExaminer actually did show every residue, whether it was high or low confidence, because it didn't previously calculate the confidence. So we recommend that everybody open their heat maps in this new version to take a look at the confidence levels and make sure that their results still make sense. So to recap the new features, we have heat map annotations and notes that you can put at various places in your project. We have the fact that charge states are no longer treated as pseudo-replicates. There's the fixed ion mobility option, where you can tell the software to not optimize the ion mobility range for each result. And there's the heat map confidence ratings. So that's what's new in HDExaminer 3.2. If you'd like to try the new software, please contact us. If you're already using a version 3 of HDExaminer and you are under a support contract, you can upgrade to this version for free. If you're not using HDExaminer 3 or you aren't under a support contract, please contact us for what your options are. So once again, this is Jeff Morrow with Sierra Analytics. Thanks for watching.